In this screencast, we'll design a data definition to represent a person's title. We'll follow our How to Design Data Definitions recipe. Let's get started with our data type definition. The first thing we need to do is decide how to best represent this information. The problem statement tells us that the user may choose to use the title unspecified, but if they do specify it, they could enter Mr., Mix, Ms., Doctor, or Prof, or other titles. The best representation for this data is an optional that has one special case, the special case being the unspecified information, and a string as the normal case. We don't want to use an enumeration because the problem statement specifies that they may have other titles, or in other words, they are not limited to the options that are listed. We'll write our data type definition, and we also need to import our CS103 library, and because we want to use an optional data type, we need to import optional. Next step is to write the interpretation. Since this is an optional data type, I know that I need to describe how to interpret the none case, or the special case, as well as how to interpret the normal case. Next is some examples that demonstrate how to form data of this type. I'll write a couple of examples that demonstrate the normal case, and I'll make sure to include one example for the none case, or the special case. Now it's time to create the template for a one-argument function that takes data of this type. We are not designing a function at this point. Instead, we are creating a template that we'll use in function designs in the future. Every time we design a one-argument function that takes a title, we'll use this template. That ensures that all functions that take this data type will look the same, which increases readability and maintainability. As always, we'll name our template function fun4 and then the type name. So in this case, fun for title. We know it takes one argument, which is of type title, and we'll leave the return type as ... because we need this template to be generic and usable in all situations. Now that we've finished the def line, let's go to the Data-Driven Templates page to help us determine what to write in the function's body. We know our data type is an optional, so I'll scroll down until I get to the one of row, because optional is an example of a one of. I can see on the right here that an optional always has two cases, and the first case is none. So we'll use an if-else template body. If x, or in our case, if t, because our parameter name is t, is none, return ... else return answer 2. The form of the second answer depends on the form of the normal data in the optional. Let's go fill in what we've got so far, and then come back to figure out what the second answer should be. If t is none, return ... else. I'm going to go back and remember that our normal case is a string, so I need to find a row in the table for string. And a string is an example of atomic non-distinct. So return an expression that operates on the parameter. Return ... and then in parentheses x, but we'll use ... and then t in parentheses because our parameter name is t. Now our template is complete, and the last thing that we need to do is fill in the rules that we use to generate this template. I'm going to go back to the Data-Driven Templates page, and if I scroll back down, I can remember that we used the one of rule that had two cases, and the first is none, which is an example of atomic distinct. Second case was string, which is an example of atomic non-distinct. So I'll write one of with two cases, atomic distinct and atomic non-distinct. Finally, we'll run to make sure there are no syntax errors. And it looks like we're finished. It ran without errors.